Greenland is losing 100 billion tons of ice a year. That's not a typo. That's not a worst-case projection. That's what satellites have already measured, happening right now while you watch this video. For most of human history, Greenland was untouchable. Ice over 3 kilometers thick. A landmass twice the size of Texas that scientists assumed would barely change within a human lifetime. They knew it would eventually melt. Nobody thought they'd get to watch it happen. They were wrong. Over the last few years, something shifted. Melt season started earlier. Glaciers that had been stable for decades suddenly broke into full retreat. And in the summer of 2012, satellites picked up something researchers didn't believe at first. Nearly the entire surface of the ice sheet showed signs of melting at once, including regions that hadn't thawed in recorded history. Scientists checked their instruments twice. The data held. This video is about why that's happening, how bad it could get, and why a remote island most people will never visit could end up reshaping the coastline of your city. Because here's the part almost nobody talks about. Greenland's ice isn't just melting into the sea, it's changing the shape of the ocean itself. Let's start with why this ice matters so much in the first place. Nearly 80% of Greenland is buried under a single, continuous ice sheet, one that holds enough frozen water to raise global sea levels by about 7 meters if it all melted. That's not happening this century. But here's the part that surprises people. This ice sits on land, not on water. And that distinction changes everything. When sea ice melts, the floating kind, sea levels barely move. The same way a melting ice cube doesn't overflow your glass. But Greenland's ice sits on solid ground. When it melts, that water is new. It goes straight into the ocean and stays there. For most of the last century, Greenland kept a rough balance. Snow fell inland, packed into ice, and slid slowly toward the coast, where it melted or broke off into the sea, roughly matching what fell each winter. A slow, steady rhythm that held for thousands of years. That rhythm is broken now, and the reason isn't simple. It's several things happening at once, feeding each other. The first is heat. The Arctic is warming 2 to 4 times faster than the rest of the planet, a process called Arctic amplification. Part of the reason is almost poetic. Fresh snow acts like a mirror, bouncing sunlight back into space. But as snow melts earlier each year, it exposes darker ice underneath. Darker ice absorbs more heat instead of reflecting it. More heat melts more snow. More dark ice gets exposed. It's a feedback loop with no breaks, and it's one of the main reasons Greenland is melting faster than climate models predicted just 10 years ago. But the atmosphere is only half the story. The other half is hiding underwater. Many of Greenland's biggest glaciers don't end on land. They end in the ocean, in deep fjords where their fronts sit directly in seawater. And that seawater has been getting warmer. So these glaciers are being attacked from 2 directions simultaneously. Warm air melting them from above, and warm ocean water eating away at them from below. Picture an ice cube on a warm table while someone pours hot water around its base. It doesn't just melt faster, it becomes structurally unstable. Cracks spread, massive chunks the size of city blocks break off in events called calving. Jakobshavn Glacier, on Greenland's west coast, became one of the fastest-moving glaciers ever recorded during this process. Its front retreating, its ice accelerating toward the sea year after year. And then scientists found something even stranger. Every summer, brilliant blue lakes form across the ice sheet. Thousands of them, visible from space, like scattered gemstones on white desert. Researchers assumed the water just ran off toward the coast. Instead, they watched entire lakes vanish in hours. Not evaporating, draining, straight down through cracks in the ice, through near vertical shafts called moulins, all the way to the bedrock below. Once there, that water acts like lubricant, letting massive glaciers slide toward the ocean faster than gravity alone would allow. Put it together and you get something scientists didn't expect. Greenland isn't melting from one cause. It's melting from at least 5 different mechanisms, all reinforcing each other at the same time. That's why the pace has outrun the predictions. Now here's where it gets bigger than Greenland. All that fresh water doesn't just raise sea levels. It pours into the North Atlantic, into one of the most important ocean systems on the planet, the Atlantic Meridional Overturning Circulation, or AMOC. Think of it as a massive underwater conveyor belt. Warm water travels north from the tropics, cools, becomes denser, sinks, and flows back south. A cycle that helps regulate weather across the entire northern hemisphere, including winters in Europe. Freshwater is lighter than seawater. Pour in enough of it, and it can interfere with that sinking process, potentially slowing the entire circulation down. You've probably seen headlines claiming the AMOC is about to collapse. Most scientists don't expect a sudden shutdown, but a gradual weakening over decades. That's a real and active area of research. And Greenland's meltwater is one of the biggest variables in the equation. Then, there's the part almost nobody expects. Sea level rise isn't even. It's not water filling a bathtub evenly. Greenland's ice sheet is so massive it has its own gravitational pull, tugging nearby ocean water toward it. As that ice disappears, the pull weakens, and the water redistributes toward coastlines thousands of kilometers away, which means cities far from the Arctic can end up absorbing more of Greenland's melt than towns sitting right next to the ice itself. New York, Miami, Jakarta. The ocean doesn't rise where the ice was. It rises where gravity sends it. And rising seas don't need to be dramatic to be dangerous. A storm today, with a few extra centimeters of baseline sea level, pushes further inland than the identical storm 50 years ago. Same wind, same rain. But water that used to stop at the seawall now goes over it. Scientists call sea level rise a threat multiplier. It doesn't create the disaster. It makes every disaster after it worse. It's already changing lives, not just coastlines. Arctic hunting communities report ice that no longer holds where it used to, changing routes their families have used for generations. Fish populations are shifting as freshwater alters ocean salinity near the coast. This isn't a graph in a report. It's someone's hunting ground disappearing under their boots. So the real question scientists are chasing now isn't, is Greenland melting? Everyone agrees it is. The real question is whether parts of it have crossed a tipping point, a threshold where the retreat keeps going even if warming slowed down tomorrow. Picture a ball resting near the top of a hill. Small pushes don't matter much while it's still balanced, but once it rolls past the crest, gravity takes over, whether you keep pushing or not. Some glaciers sit in valleys shaped in a way that could trigger exactly that kind of runaway retreat. Others might stabilize if warming slows. The honest answer is, it depends on the glacier, and scientists are still mapping which ones are near that edge. Here's what should actually stick with you from all of this. Geological change used to take thousands of years, slow enough that no single person could ever witness it. Mountains rose over millions of years. Coastlines shifted so gradually nobody noticed in their lifetime. Greenland broke that rule. Researchers who started measuring this ice sheet early in their careers are now comparing today's data to numbers they personally collected decades ago, watching a geological scale transformation unfold inside one professional life. That's not a metaphor. That's the first time in human history it's happened. And this is where I think most explanations of climate change get it wrong. They treat it as an abstract number, a fraction of a degree, a line on a graph. What's actually happening in Greenland is not abstract. It's a lake draining through solid ice in under an hour. It's a glacier the size of a small country losing its grip on the seafloor. It's gravity itself rearranging where the ocean goes. The good news, and there is good news, is that this isn't a story about inevitability. Every model scientists run agrees on one thing. The range of possible futures for Greenland is still wide open, and what happens depends almost entirely on decisions being made in the next few decades, not on physics already locked in. Coastal cities are already redesigning seawalls and updating flood maps based on this data. Preparation still has time to work, but only if it starts now based on what the ice is actually telling us, not what we assumed 10 years ago. Because that's the real headline here. Not that Greenland is melting. Everyone already knew that was coming eventually. The headline is that we're the first generation in human history able to watch a piece of the planet, this large change in real time, measured to the ton, tracked by satellite, year after year. The ice doesn't lie. It doesn't exaggerate for views, and it doesn't downplay for comfort. It just keeps recording, one melt season at a time. The clearest evidence we have of how fast this planet can change once it starts. The only open question left is whether we're paying attention fast enough to keep up with it.